Bismillahirrahmanirrahim. This is lab number 5, and in this lab we will study about this is the introduction to the Matlab. So introduction to the Matlab, we will study some basics mathematical operations, just like how we can declare a variable in Matlab, some mathematical operation related to the matrices. How can a matrix can be declared? What is the row matrix? What is the row vector, column vector? Similarly, the square matrix. And some of their operations, just like how to take the inverse of the matrix, how to take the determinant of the matrix. Similarly, how to take the transpose of the matrix, and so on. Similarly, we will in this lab we will discuss about how to plot a sine wave and how to label the sine wave, the X label, the Y label, and the title of the lab. Similarly, we may use if we are interested to find more plots in the same figure. So how we can use the plot command by using the hold on command. Hold on. Similarly, we will use how to use the legend to make our plot more visible and more easier to understand. The last topic in this lab will be how to use the subplot. We are having one figure and we are having multiple plots, and we are interested to plot multiple plots, subplots in one figure. So that will be also included in this lab. Okay. So this is an introduction to the Matlab. Matlab stands for the Matrix Laboratory. This is how it looks like. This is the Matlab environment. This is how it looks like. Or this is how it looks like. There are three types of windows in Matlab. One is the editor window, in which we can write up a program. Similarly, we are having a command window in which there are two insertion signs, or this is a command window, which we can give a command by line, and there might be a line-to-line execution of the program as well. Similarly, here in the left corner, on the left hand side, there is a current directory over here, and there is a workspace that will appear, and I will show you how it appears, right? So for the clarity, I'm going to minimize this command window. We will work in this command window as well. In the start, we will work in the command window. This is the workspace. So up till now there is no variable has been declared, so that is empty. Okay. So Matlab environment is the editor window. We are having the command window. We are having the workspace. We are having the current directory in which we are working. And similarly, there is another window that is the graphical user interface, and that is the Simulink. That is the graphical user interface with the Simulink. Okay. workspace current directory. This is how it looks. The workspace. This is the current directory. You might have the script file, that is the editor window, that's the script file here. Okay, getting MATLAB help. So in the command prompt, we type any command, just like we can use the help command. For example, I'm interested to I'm interested to find about logarithm, for example. All related stuff that will be appeared on the logarithm, right? So you can use the help command, logarithm not finds. Perhaps there is a, I might use another word. There is some spelling mistake, so I can write the Laplace. So Laplace. Also, I can use the help LTI command window. And if I'm interested to find, I know what is the command, for example, LTI or some other function, so I can help it out in the command window, and all the related stuff will appear here. So that is how the LTI, this is all related stuff, that is the helping material will appear in the command window. Similarly, we can use the look for command as well. For example, we don't know about the exact command, what is the keyword, so we might use the look for command as well. So you might look for example, I'm look for sub, so look for the legend. Let me write legend. So it will appear in the command window. Well, you can learn, MATLAB itself can provide you the platform. You can get help from the MATLAB software. There is a help here in the corner. This is the help, and if you can write anything here, if you can search it out. So MATLAB itself can provide you the best opportunities to learn. You can play with this with the MATLAB. Okay, there might be my computer is a bit slow, so there might be some infinite loops. So you can abort that loop. For example, in the command window, you have write the look for the legend, and if you want to abort this operation, so you might write the Control C. So that operation will be aborted. That will be stopped. Okay, so help windows also help when open the separate help windows for the navigation. MATLAB variables. If a statement is terminated with a semicolon, if you declare a variable and that variable is terminated with a semicolon, so no result will be displayed. For example, you are and similarly we can use the CLC for clearing the command window. CLC, now the command window is cleared. Now we are having a variable, and that variable is assigned the value of 5, and that will appear execute to 5. And when we write x equal to 5, and that is followed by the semicolon. So the statement will execute. The value of the 5 will be assigned to the x variable, but it will be suppressed in the command window. We can't see. We can't see it. So by writing the semicolon, the statement can be suppressed. Though it will be functional, but 5, this is a variable. Okay. So we are having another variable, and that is equal to, let's say that is equal to 2 multiply by s plus 1. So this is another variable. So we have to define the s, that is equal to the function that is equal to df, and s. First of all, we have to define what is s. This is a variable, and afterwards we can use the command. It will be executed. So y is equal to s plus 1. This is a row vector, and this is a polynomial as well. The order of polynomial of order 1. In this way, we can declare the polynomial as well. Variable names are case sensitive. It means that capital A is different from the small a. Similarly, variable name must start with the letter followed by letters, digits, and underscores. For example, we cannot start from 1 to 3. It might be a variable, and for a variable, for example, lab underscore u, and that will be some variable, and with the variable is assigned false value and false value. So this is lab underscore u. We can declare the variable as well. Similarly, variable names and their types do not have to be declared in MATLAB. Their types, like this is a double, this is character, long, things like that cannot be. It's not important to declare that in MATLAB. Any variable can take real complex integers values. The name of variable is not accepted if it is reserved word. For example, it is LTI, or it might be INV. I'm using the reserved word. For example, I'm using INV. That is equal to 2. Inverse INV stands for the inverse of the matrix. So it will not. Okay, that is INV of the matrix. So here is a error, because this INV of a matrix, that is a reserved word, so it cannot be declared as a variable. Similarly, there are some reserved words. For example, if you can declare a variable and without any, there is a variable, or for example, you are interested to find you have declared a row vector that is equal to num1, 2, and then I mean enter, that is equal to 3, 4, and we are interested to find a transfer function of the num versus den. So here transfer function is not assigned to any other variable. So by default, ANS answer will be used, ANS. So this is a variable. That is by default, that is, if any variable is not declared, so it will be assigned to the answer, ANS answer. Similarly, we are having some other reserved words, variables. For example, EYE, so that is identity matrix. Identity matrix 5 plus 5. So that will be identity matrix. Similarly, we can use the pi. What is the pi? Pi, and that is equal to pi 3.1416. MATLAB by default takes up to the 4 integers 1, 2, 3, 4. If we are interested and we want more precision, so we might use the word. We might use a different format, and that might be format, and that would be long. And afterward, we declare pi, so that value will be up to the 14 digits. The default format is short. So let me write it short. Similarly, NaN, this is not a number, and INF stands for the infinity. So this is the infinity, INF. This is the reserved variable, reserved words. Similarly, EPS stands for the epsilon. Okay, there are some commands involving variables. For example, when we write who, who, all date variables which are declared in this command window will appear, just like ans, lap underscore u. Then is another variable num x, inverse of inv. It's not inverse, this is inv, a variable. S, y, these are different variables, and you can see these variables in the workspace. These are all variables are also, you can see all the variables here in the workspace as well. Okay, and this is the current directory. So let me minimize the current directory. If I can write the command whos, whose, all the variables will appear. Their type, their size will appear as well. LAP underscore U, 1 cross 1, and that's 8 double. Similarly, Y 1 cross 1 matrix is a row matrix, so 1049 TF. Similarly, we can use some commands. For example, writing CLC. So the command window will be cleared. CLC, the command window will be cleared. And you people are familiar with most of the commands. Similarly, I can write the clear all. So all the variables that are declared will be cleared. Similarly, we can use other commands like close all. So those all figures which are declared, which have been plotted, so that will vanish by using the command close all figures. Close all. And as discussed, you can use the Control C for aborting any operation if there is any infinite loop that is going on in the command window. So you can abort, you can start that infinite loop by just pressing Control C. This is how the variable is assigned to the capital A. Similarly, we're having, if you are interested to find the volume of the cylinder, so here pi, this is a constant value, radius is the variable, height is the variable. You have to define the radius, we have to define the height, and that will be stored in another variable that will be the volume of the cylinder. So this is how different types of the variables are declared. X is equal to 111. Here name, number underscore of underscore student, that is equal to 75. Similarly, we can declare a variable in the form of the string by using the single quotes. Single quotes are used. For example, I'm using str, that will write a string, and that is equal to, so it will UATP shower. It will appear as a UATP shower strings. This is also a row vector. Radius equal to 5, area pi multiplied by radius to the power 2. This is how we can take the power. This exponent, this is the power 2, so radius square, pi r square. So that will be stored in the area and many other values. There are some arithmetic operators you people know. This is the positive, this is the negative, and here dot followed by the asterisk or the star. Here dot is followed by the forward slash. This is the right division. Here dot is followed by the backslash. So this is the left division. And here dot is followed by exponent or the power. So if we are having this dot followed by the asterisk, this is used for the element by element multiplication. For example, let me first declare a matrix. Let me first declare x a variable, and that is a row vector. 1, 2, 3, 4. So it will be a row vector. 1, 2, 3, 4. This is a row vector. Similarly, if I can define a square wave matrix, and let me, if I'm interested to find the column matrix, the column vector. So x, this is the 1, 2, 3, 4. After the square bracket, we'll use the apostrophe sign. Apostrophe. That apostrophe sign used for the transpose of the matrix. So now it will become a row. It will become a column vector. So if we can write x is equal to the square brackets 1, 2, 3, 4, and there is no apostrophe, so it will be a row vector. But a square bracket, a row vector followed by this, followed by the apostrophe, it will be treated like just a transpose of the matrix. It will be column vector. Similarly, how we can declare a square matrix? We can declare a square matrix. This might be a square matrix. It might be a rectangular matrix as well. So we might write the square brackets, and is 1, 2. Now this semicolon is used as a row separator. It will separate, for example, 1, 2 is one row, 1, 2 followed by the semicolon. So another row will start, another row will start, 3, 4. Similarly, semicolon. So the third row is starting 5, 6. You can write also you can write the comma between 5 and 6. You might give a space between 5 and 6, and will be okay. So this is how it looks like. We are having a rectangular matrix. The dimension of the matrix is 3 cross 2. Means you're having 3 rows and 2 columns, m cross n. So 3 rows and 2 columns. So the operation of the matrix, if you are interested to find the element by element. So first of all, we are finding the usual dot product, or the cross product, the dot product. That is the normal mathematical operation of the two matrices A steric A multiplied by A. This is the normal mathematical, this is normal matrix multiplication. That will be equal to A cross A. Okay. So here A cross A, and this is these two. If, for example, I have declared a matrix, and these two matrices will be only conformable for the multiplication if the number of the columns of the A matrix is equal to the number of rows of column B. So here in this case, these two matrices cannot be multiplied. You're having a, let me write, for example, this is a square matrix. and I'm interested to the 1, 2, 3, 4, and I'm interested to find the multiply the two matrices A steric A. So this is the normal mathematical multiplication of the two matrices A steric A. 7, 10, 15, 22. Similarly, if there is a point by point multiplication between the two vectors A and A, for example, one entry is 1, here is 2, 3, and 4. So in this case, A dot followed by the steric and this the vector A. So 1 will be multiplied with 1, this will be 1, 2 multiplied will be with 2, element by element multiplication, 3 multiplied by 3, and 4 multiplied by 4. So here you can see 1, 4, 9, and 16. Similarly, you can use another command. This is A, and that is steric followed by the exponent to the power 2. So 1, 4, 9, 16. If you are interested to find the cube, there might be 3 times multiplication of the same number, element by element multiplication. So here 1, 2 is 8, for 3 this is 27, and for 4 this is 64. Okay, so this is how we can use the dot followed by the asterisk. This is the element by element multiplication, might be element by element division, right division, left division, and similarly exponentiation. There are some logical operators and or not, less than equal. So you people are also familiar of these logical operators. This is how we can define the variables.